Hello everyone, in today's topic we are going to talk about Introduction to Probability, and we are going to focus on simple probability. Did you know that one of the pioneers of modern probability theory, Blaise Pascal, was told not to study mathematics until the age of 15? However, he did not stop him from excelling in mathematics later on his life. That's why we have Blaise Pascal as one of the famous mathematicians. What is probability? The probability of any event is the measure of the likelihood or chance that the event will occur. For example, we may wish to know the chances of winning a competition. Knowing this probability can help us to decide the amount of preparation needed before we participate in the competition. The greater the probability of an event, the greater is the likelihood that it will occur. Simple probability. Consider the event where we obtain a prime number when we roll a dice. So, to recall, prime number are numbers that have exactly two factors, one and itself. The possible outcomes of this event are 2, 3, and 5. Let A be the event that the number rolled in a dice is prime. So the favorable outcomes of A, or the event that the number rolled in a dice is prime, are 2, 3, and 5. So they are prime numbers. So the number of outcomes of A is 3. What is sample space? Sample space is the list of all possible outcomes. In the case of the dice, the sample space consists of the numbers 1, 2, 3, 4, 5, and 6. Thus, the total number of possible outcomes is 6. To calculate the probability of an event A, we can use the following formula. So the probability of an event A occurring equals the number of outcomes favorable to A over the total number of possible outcomes. Example for this one, A is the probability that the number rolled on a dice is prime. So we are going to have the probability that the number rolled on a dice equals 3 over 6. So the number of outcomes favorable to A is 3 over the total number of possible outcomes, which is 6. So we are going to reduce it to the lowest term, so we will be getting 1/2. So why we have 3 as the number of outcomes favorable to A? So we have 2, 3, and 5. So that's why we have 3, okay, in the denominator. And the total number of possible outcomes, we have 1, 2, 3, 4, 5, 6. And always reduce the probability into its lowest term. The following are some special properties of probability. If A is an impossible event, the probability of getting A, or the probability of that event, equals 0. Impossible meaning there's no chance that it will happen. If A is a sure event, then we have the probability of A equals 1. And for any event, probability of A plus probability of not A equals 1. So if we are going to transpose the probability of A on the other side, so we will be getting the probability of not A equals to 1 minus the probability of A. So whatever the probability of any event, and then we are getting the probability of not doing that event or result. So we are just going to subtract it from 1. So take note that for any event A, the probability of A is greater than equal to 0 but less than 1. So it will not exceed to 1 and it will not be negative. Example number 1, an unbiased dice is shown. Find the probability that the number obtained is an odd number. And then a multiple of 3, not a multiple of 3. Then the last one, the probability that the number obtained is 9. So in here, in getting an odd number, so let A be the event of obtaining an odd number. Then the favorable outcomes of A are 1, 3, and 5. They are all odd. And then the number of outcomes favorable to A is 3. So therefore, the probability of A equals 3 over 6. So reducing it to the lowest term, we have 1/2. Now let us go to letter B, a multiple of 3. So let B be the event of obtaining a number that is a multiple of 3. Meaning, if we are talking about multiple, so let us start with 3 times 1, 3, 3 times 2, 6, 3 times 3, 9. So those are the multiples of 3, okay, and so on and so forth. And from here, the favorable outcomes of B are 3 and 6. The number of outcomes favorable to B is 2, so there are 2. So we have the probability of B equals 2, the number of outcomes favorable to B over the total number of outcomes, which is 6. So reducing it to the lowest term, we have 1/3. Now let's move on to letter C, not a multiple of 3. Since we already computed for the probability of B, which is equal to 1 over 3, the multiple of 3, we are just going to subtract it from 1. So the probability of not getting a multiple of 3, so 1 minus 1/3, which is equal to 2 over 3. Now let's move on to letter T. So what is the probability that the number obtained is 9? The number 9 is not found on the dice because it's only 1 to 6. Thus, this is an impossible event, so therefore, the probability that the number obtained is 9 equals 0. So it is impossible that we are going to have number 9 because in a dice, we only have 1 to 6. Now let us go to example number 2. A card is randomly drawn from a standard deck of 52 playing cards. Find the probability that the card drawn is a picture card, a heart or a diamond, not a heart, and for letter E, the Queen of Hearts. First, let us study about the deck of cards. So a deck of cards has 4 suits. So this one is the spade, diamond, club, and heart. Each suit has 13 cards. It composed of ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have jack, queen, king. And jack, king, and queen are called picture cards. So for example number 2, we have a card is randomly drawn from a deck of 52 playing cards. Find the probability that the card drawn is a picture card. So from here, we all know that we have 12 picture cards. So we have jack, king, and queen. Then we have to multiply it to the 4 different suits. So 3 times 4 is 12. Then the total number of outcomes, of course, we have 52. So 12 over 52, or reduce it to the lowest term, we have 3 over 13. Now a heart. So we have 13 hearts. So 13 over 52, reduce it to the lowest term, we have 1/4. And then we have a heart or a diamond. So we have 13 hearts, and then the word or is plus, and diamonds we have 13. So from here, we are going to add 13 plus 13, so it will become 26 over the total number of outcomes, 52, reducing it to the lowest term, it is equal to 1/2. Now let us have letter D, not a heart. Since we already computed the probability of getting a heart in letter B, so we are just going to subtract it from 1. So we have 1 minus 1/4, which is equal to 3/4. And for the last one, the Queen of Hearts. So in here, how many Queen of Hearts do we have? We only have 1. So therefore, it is 1 over 52.